Hey there! If you're prepping for the ASVAB, you know the general science section can be a real mix of topics. So today, we're looking up, way up, and tackling Earth's atmosphere and weather. Let's jump right into what you've got to know to nail these questions.
So let's start with a pretty big question, right? What's the difference between our awesome, living planet and, say, a cold, dead rock floating in space? The answer is all around us. It's our atmosphere. This amazing, multi-layered blanket of gas is what makes everything else possible.
All right, we're going to take a journey from the ground we're standing on all the way to the edge of space. But before we blast off, let's talk about what's happening right here, on the surface. This is the stuff that creates the daily forecast you see on the news, and it's definitely something you'll need to know.
Okay, so you've heard of weather fronts, but what are they? Well, a front is just a boundary line where two different types of air, like warm and cold, smack into each other. With a cold front, that dense cold air acts kind of like a wedge, shoving the warm air up really fast. That can cause some pretty dramatic clouds and storms. A warm front, on the other hand, is a bit more chill. The warmer air gently slides up and over the colder air, which usually brings more widespread, gentler rain.
And when you push air up, you get clouds. Here are the three main types you'll want to recognize. Way down low, you have stratus clouds. Think of those flat gray sheets that cover the whole sky on an overcast day. In fact, if they're on the ground, that's just fog. Then you've got your classic puffy cotton ball cumulus clouds. Keep an eye on those, though, because they can grow into huge cumulonimbus clouds, which are basically thunderstorm machines. And way up high, you'll see those thin, wispy cirrus clouds. They're actually made of ice crystals and usually mean the weather is pretty fair.
All right, we've got a pretty good handle on what's happening on the ground, so now it's time to start our climb. Let's head up that atmospheric ladder layer by layer and see what this planetary shield is all about.
On our way up, we're going to pass through four main layers. Starting from the ground and moving up, we've got the troposphere, then the stratosphere, then the mesosphere, and finally, the thermosphere. So let's take a closer look at each stop on our trip.
First up is the troposphere. This is our home. It's where we live, it's where we breathe, and it stretches up about 10 kilometers. Now, here is the most important thing to remember for the ASVAB. Literally, all the weather we just talked about, the fronts, the clouds, the rain, the storms, all of it happens right here in this layer.
All right, climbing higher, we enter the stratosphere. The number one thing you have to remember about this layer for your test is the ozone layer. This part of the stratosphere acts like our planet's own natural sunscreen, soaking up most of the sun's harmful UV radiation before it ever reaches us. Super important.
Our next stop is the mesosphere. In this layer, the temperature just plummets, making it the coldest part of our entire atmosphere. It's also our first line of defense against space rocks. Most meteors burn up here, creating those beautiful streaks across the sky that we call shooting stars. Pretty cool, right?
And our last main stop is the thermosphere. Now, this one's a little weird. The temperature here skyrockets. It can get thousands of degrees hot because it's getting hit with so much solar radiation. But, and this is the strange part, it wouldn't feel hot at all. The air is just so incredibly thin up there that there aren't enough molecules to actually transfer that heat to you.
So we've made it to the top. But why is all this on the ASVAB? Well, because for the US military, this isn't just a science lesson, it's strategy. Let's take a look at how the sky directly impacts military operations. For pilots, sailors, and soldiers on the ground, understanding the atmosphere is way more than just deciding whether to pack a raincoat. Weather conditions are a critical factor that can literally decide if a mission succeeds or fails.
Just think about it for a second. Thick cloud cover can stop a fighter jet from taking off, or completely hide a target from a spy plane. A naval operation could be a total success or a total disaster based on the sea state, which is controlled by wind and pressure. Even our super advanced satellites can get messed up by storms in the upper atmosphere. And for troops on the ground, a sudden blizzard or a heat wave changes everything.
Okay, now that we've covered the science and why it's so important, let's put what you've learned to the test. Here's a practice question, just like one you might see on the general science section of the ASVAB.
Which atmospheric layer contains the ozone layer? Is it A, troposphere, B, stratosphere, C, mesosphere, or D, thermosphere? Take a second and think back on our climb up that atmospheric ladder. All right, you got your answer? The correct choice is B, stratosphere. That's the one with our planet's all-important sunscreen. If you got that one right, fantastic job.
And here's the official breakdown, just to lock it into your brain. The stratosphere is above the troposphere and is the region that contains the ozone layer, which absorbs most of the sun's ultraviolet radiation. That's the key fact you need to hold on to.
And there you have it. From knowing the difference between a warm and cold front, to spotting the three main cloud types, to keeping the layers of the atmosphere straight, getting these concepts down is absolutely going to help you knock this part of the ASVAB out of the park.
So, we've just peeled back the layers of the sky above us, the very thing that makes all life on this planet possible. As you keep studying, just think about that for a second. What other invisible forces, like gravity or even the code in your DNA, are shaping your world at this very moment? Thanks for joining me on this one.